or would you be allowed to graph it? You're guys aren't allowed to use calculators, are you?
We are not.
You're
But
not. Okay.
she does do the little drawing graph, like visuals just on the side for us.
Okay. Well, yeah. So the thing is, this one it does approach from here. So it's the minus infinity to the horizontal asymptote, which is that value of 5 there. The horizontal asymptote is y in this case. It's the y equals 5. So you can see there's some similarities there, things that you can reuse. The range and the horizontal asymptote very much related. When we do a logarithmic problem, the domain and the vertical asymptote will be very much related. Okay. All right. So next boxes to fill out here, we're going back to the original thing. It says y equals -3, x -3 plus 5. You're putting 0 in for x. So this is -3 to the -3 power, which is really -1 over 3 to the power of 3. It's only the 3 that's being raised to the -3 power. So this is -1 over 27 plus 5 over 1. You have to make a common denominator of 27. So it ends up being 134 over 27. Does that look okay to you?
Yes.
Okay, now the next thing is the x-intercept. So you're setting this whole thing equal to 0. First thing is to subtract 5 from both sides. -3 to the x -3 power equals -5. Since they both have a negative, you can cancel those out. So it's 3 to the x -3 equals 5. If you read the answer, it says your answer will be in the form of log base blank of blank. You have to take the log base 3 of both sides. The reason it's base 3 is because that's the base of the exponent. The exponent can come out in front. So this becomes x -3 log base 3 of 3 equals log base 3 of 5. And then you divide both sides by this, but this is really 1, so there's nothing to do there. It ends up just being 1. And so you really have x -3 equals log base 3 of 5. And then you add 3 to both sides. So x equals log base 3 of 5 plus 3. So I think there's 3 places to put answers. I
Yeah.
think you've got to put like 3, 5, and 3. We'll do it. It's not visible in the pictures I have, so.
Yeah, it is like that. It just cut out.
Okay. So if that's clear, we can go on to number 2.
Yes.
Okay. All right. So this is a higher order substitution problem. You end up letting u equal 4 to the x, and then when you square 4 to the x, that becomes 4 to the 2x. Reason is exponent to exponent, you multiply. So your equation becomes something more manageable, something more that you're used to. 5u squared plus 4u minus 1 equals 0. This will be 5u and u. And so you have to figure out where to put the factors of -1, which is 1 and -1. If you think real hard, you'll get something like this. And then you set each of these equal to 0. So right now it's u equals 1/5 and u equals -1. That's what they're looking for in the blanks here. Then you have to try to um, solve them. And they're sort of implying that one works and one does not work. All right, so for the 4 to the x equals 1/5, you take the log base 4 of both sides. And the exponent comes out in front. Basically, the left side becomes x log base 4 of 1/5. This is okay. This one does produce a solution. You might wonder why. You'll see why when we do the next one. The next one is 4 to the x equals -1. Same thing, you take the log base 4 of both sides. So on the left, it becomes x. So the domain of a logarithm is that the inside part has to be greater than 0. This is not greater than 0, -1, so there is no solution. So in terms of how you answer, log base 4 of -1 equals no solution. Log base 4 of 1/5 does work. Is that clear?
Yes.
Okay. All right. Question 3 here is another rewrite problem. Kind of like what we've been doing, but now going the other direction. So I'll give you an example here. Let's see if you can make this work. Let's say it's log base 3 of x equals p. The answer is that it becomes x equals 3 to the p power.
Would it be
And actually, I'm sorry. Let me make this backwards so it fits yours. It would be 3 to the p equals x. So what? How does that map for your problem here?
um would it be 2 to the k equals y?
Yes. Very good. Now, you do have to show work on these. Like it's not like you can just
Um
get or not because if we would do the next few differently if you didn't have to show work.
we technically like we don't have to turn in shown work, but I just whatever we do like on the tutor I write as we go.
Okay.
So I have
Okay.
it.
All right, and that's fine. I'm just trying to minimize your pain and suffering here of this. It can be kind of overwhelming. So this is actually three, kind of three problems. I know it's one, but it's really three. So the first one here, uh, you have to rewrite 125 as 5 to some power. Can you tell me what that power is?
Um is it to the fifth or 5 to the 5?
5 to the 5 is 5 times 5 times 5 times 5 times 5. There's a lot of fives. You may find that that is too large.
Is it 4?
So like, for example, 5 times 5 is 25, and that's another 25. Even if you go 5 to the 4, that's still pretty big. Um,
3?
it is 3. And 1/5 is really 5 to what power?
Um
Maybe from earlier in the course.
is it 0?
But anything to 0 power is 1. It's actually -1 and that's how you get the flip. So the reason that's important is because it becomes log base 5 of 5 to the power 3 over log base 5, 5 to the power of -1. The shortcut here is that it becomes just the exponents, and that becomes -3. All right, let's look at the next one here. So log base 2 of 2, it really has an exponent of 1. And this one on the bottom here is really log base 6 of 6 to the -2 power. So these just become the exponents. The exponents are 1 and -2, which becomes -1, 1/2. Last one here in the grouping. So this 1/2, the 1/2 here can come in front of the, or come to the exponent of 9. So this is really e to the natural log of 9 to the 1/2 power, which is really the square root of 9, which is really 3. And then the e and the ln, they undo each other, so it just becomes 3 over the 2 there. Any questions on that?
No.
Okay. So to solve the exponential equation for x, and the first step here, first log base, type in the first step of writing a log below. So I don't really follow this, because the first thing I actually do is divide both sides by 2. And then you would take the log base 4 of 4 to the 4 plus 3x equals the log base 4 of 6. And then you'd bring this 4 plus 3x out in front. So I don't know. I guess this is what it wants. That doesn't seem right.
Would it just be log base 4 of 6 equals?
Okay, yeah, that actually does sound correct to me. Yes, that looks better. Okay. Any good catch on that? They don't actually want you to solve it, which is great, because that just means more work. All right, next one here. This is an expanding problem. One of the things I'll do to maybe help here is that it's really h to the 3/4 power over 5 to the 1/2 power y squared. Have you been doing any problems like this in class?
Um, a couple.
Okay.
These are
So,
definitely ones I like just remember how to do in my head from last year, is kind of looking at them.
yeah,
But
so
it's
the
just fractions.
if it's on top, it's positive. If it's on the bottom, it's negative. If there's an exponent, like let's say it's 5, 6, 7, those come out in front. See if you can use that to tell me what the right answer is.
Would it be the first option?
Take a look here. Looks pretty good. Yep. Go with that one. Okay. Ready to move on here to number 7?
Yes.
Okay, so the first thing is that you typically move the numbers in front, if there are any, top. So it's the natural log of 4 squared, which is really the natural log of 16, plus the natural log of 2 minus the natural log of 4 plus the natural log of 3. So typically, you think of this as reverse. If it's positive, it goes on the top. If it's negative, it goes on the bottom. And then you try to reduce if you can, like 16 and 4 go together. This becomes 8, natural log of 8 over 3. Is that okay?
Yes.
All right, so 8 is kind of like a reset here of some of the other problems we've been doing. To the first, like it's kind of like a reset of the first problem we did. Some of the same things apply. This is another exponential problem. It's e instead of a number. Domain is always minus infinity to infinity. The graph of this looks something like this. So the range is the horizontal asymptote to positive infinity. We'll actually do the horizontal asymptote first. It's this number on the outside here. It's y equals -3. So the range is -3 to positive infinity. I don't see anything else for that problem.
Yeah. There's also the X and Y on this one. I just don't think it's an either.
So we're talking about the x-intercept and the y-intercept.
Yes.
Which one's first?
Y-intercept.
Okay, so the y-intercept is when x equals 0. So that's e to the 0 minus 2 minus 3. It's e to the -2 minus 3. So I'm not sure how you have to enter that, but somehow that's what you're going to try to do.
Okay.
Is that okay?
Yes.
All right, now the x-intercept is setting the whole thing equal to 0. E to the x minus 2 minus 3 equal to 0. To solve, you add 3 to both sides. E to the x minus 2 equals 3. You take the natural log of both sides. On the left, it just becomes the exponent. Then you add 2. So x equals the natural log of 3 plus 2. So I'm sure that's sort of there as an option or way to enter that. Any questions on that?
No.
All right, so new problem here. The way to solve this is to make the bases the same. You have to make 1 over 10 equal to 10 to some power. What would that exponent be from an earlier problem we did?
-1.
-1. That's good. And then 1 over 100 is 10 to another power here. What would that be?
-10.
Oh, what about 100? 100 is 10 to what power?
2.
2.
So -2.
There you go. So this on the left becomes 10 to the -1 to the 2x minus 3 power, 10 to the -2, 3x minus 4 power. When you have an exponent to an exponent, you multiply. So it's 10 to the -2x plus 3 power, 10 to the -6x plus 8 power. So we're just multiplying the exponents. I mean, they're really in parentheses. Is that clear so far?
Yes.
Okay, so now you set the exponents equal. Would you solve this equation for x, please?
Yes. The x equals 5/4.
Yes. Um, um, algebraically solve the equation to the answer in the answer. All right, so the property we're using here is that log base b of a plus log base b of b becomes log base b of a times b. All right, and so the reason that's useful here is you're gonna rewrite this as log base 9 of x times 6x minus 7 equals 1/2. So this is a, and this whole thing is b. Is that clear?
Yeah.
So to undo the log, you use a base of 9. So on the left, it becomes x times 6x minus 7 equals 9 to the 1/2 power, which is really the square root of 9, which is really 3. Is that okay?
Yes.
All right, now we're going to distribute in x into the 6x minus 7. 6x squared minus 7x minus 3. Well, it ends up equaling 3, so you bring the 3 over. Okay. All right, now to solve this, there's a number of ways to solve it. I mean, there's factoring, which is the best way. Quadratic formula, not needed, but does work. So the factoring here is you take the first and the last and you multiply them together. So 6 times -3 is -18. You're looking for two numbers that multiply to -18 but add to -7. Can you take a moment and see if you can come up with those?
Yeah.
those answers.
Is it -9 and 2?
Yes. So it becomes minus 9x plus 2x. You're splitting apart the minus 7x. And then you're factoring out the GCF. So they both have a GCF of 3x. So that becomes 2x minus 3, 2x minus 3. You're going to put plus 1 here in parentheses. And then you're factoring again. So you end up getting 3x plus 1. You're setting each of these equal to 0. So setting 2x minus 3 equal to 0, 3x plus 1 equal to 0. Would you solve those for x for us, please?
Yeah. Is it x equals 3/2 and x equals -1/3?
Good. Now, sometimes you get so, they call it down in the weeds, like you're so far into this problem, you forget like what you were even trying to do. Um, Only one of these answers works based on the way the answer space is written. Um, you've got to consider the domain. The domain is that x is greater than 0. So the answer that's negative doesn't work because when you put that back in, it's not in the domain. So the extraneous solution is the second one. 3/2 is the first one. Is that okay?
Yes.
Before we move on. All right. Moving on to number 12. I don't even know what the question is asking for, but you're gonna bring this 1/4 inside here. I says to simplify something. So it's log 16 e to the power of 8, all to the power of 1/4. So really you have to rewrite 16 as 2 to some power. What is the best way to write that? 16 is 2 to what power?
4?
Yeah, 2 to the 4th. So this is really log 2 to the 4th b to the 8th to the 1/4 power. So you're going to multiply those in. So it becomes 2 to the 1, 4 times 1/4, 1, and then 8 times 1/4 is 2. Do you see that answer there?
The last one. No,
I
it's
disagree.
yeah, never mind. Uh, the first one?
Yeah. All right. So we're on to number 13. The x-intercept is setting the equation equal to 0. So we actually did one like this. I'm gonna draw your attention to that. We did one like this earlier. Might have been the first one. Yeah. So could you Would you look back at your work for the first one and see if you could try this one on your own?
Yes.
It's almost identical. So
Um, would it be log base 5 times or of 6 plus 3?
like this.
Yes.
Yeah, that looks correct. Okay, there's more though. We're not like all the way through that one. Um, so the end behavior comes from the graph. Um, as I mentioned a few times, it will approach a horizontal asymptote. The negative tells you that it's going to come from the bottom. This negative in front here tells you it comes from the bottom. So as you go to the right forever, I'm going to do the bottom one first after I get the screen to resize because that was silly. Okay, as you get the as you go to the right forever, it goes to the horizontal asymptote. As you go to the other direction, it goes to negative infinity. So you can think of it as, left, right, and so on. Is that everything for 13? I can't tell.
Yes.
Okay.
Okay.
Finally, a calculator question.
Yes.
Not sure that you even need it for this, but okay. Well, yeah, the way they read the numbers. Okay. Right. What is the initial mass? They're saying, hey, T is 0. And you could put that in for T. You may be fine. Hang on just a second, be right back with you. All right, I apologize for the delay. Did you get 50 as your initial mass?
I did.
Good. So to do the next part, you're putting 3,000 in for T. So it's 50 times 1/2, 3,000 over 1,600. I guess this is where you doesn't say to round. There's no way that works out perfectly. Um, did you try this yet?
I
Yeah,
have
see, it doesn't, this does not work out. Like, so I don't know what to tell you. Is there any rules for rounding? Maybe at the top there that I
no, it doesn't say
don't know what
anything.
to tell you. Then it's 13.63. Maybe check with the teacher if you can before you have to submit. If you can't, that's okay, do too.
Okay.
Oh, it says thousandths down here, so that's 3 decimal places. Let's go out one more. I know it's for the next problem, but maybe the person who wrote this is consistent. All right. So for this one, it's we're setting the entire equation equal to 15. And then we're solving for t, which is, let's see here, we gotta do this weird thing that they want you to do. Okay, you're gonna divide both sides by 50. So if you reduce that, 5 goes into both. That's 3/10. So 3/10 equals 1/2 t over 1,600. So you're gonna take the log. You're gonna take the log base 1/2 of both sides. And on the right, that's where it becomes just the t over 1,600. So on the left, that's the answer that they're looking for. Base 1/2, 3/10. And then we have to solve this. So it's this number over here, but you have to multiply by the 1,600. Here's thousands. Wow, really quicky. 2,779.145. You may want to double check that on a calculator.
Okay.
Let me know we can move on to the next one.
I'm
We
ready.
should we should be able to get these both done here. All right. So the triple, oh my gosh, these are horrible problems. Okay. So we want to get to 3,000, starting with 1,000. That's 1 plus 0.0245 over, for the monthly one, n equals 12. For the daily, it's n equals 365. And continuous, it's PERT. That's actually the easiest one of them to do. So it's over 12 to the 12 times t power. So this is kind of a mess to solve. It ends up being 3, whatever this thing is. And you can put that in the calculator if you want. You can wait till the end. You end up taking the natural log of both sides. So you get 12t natural log of this 1 plus 0.0245 over 12. So t ends up equaling the natural log of 3 over 12 natural log 1 plus 0.0245 over 12, like that. And that goes into the calculator. You gotta match parentheses. All right, so that ends up being, and again, doesn't, oh, thousands, 44.887. The only difference with the daily in the 12 becomes a 365. So that's 44.843. And then pert's probably the easiest. You get 3,000 equals 1,000 e to the 0.0245t. You undo by dividing by 1,000, so 3 equals e to the 0.0245t. Take the natural log of both sides, and ends up being the natural log of 3 divided by 0.0245, like that. Which ends up being 44.841. And that is it for that one. All right. Any questions on that before we move on to the last one?
No.
All right. Don't know why this one's a calculator. Can be done by hand pretty easily. The base when it's not written is 10. So you undo with 10 to the log base 10, 2x minus 3 equals 10 to the 3. 10 to the 3 is 10 times 10 times 10, which is 1,000. And you have 2x minus 3 equals 1,000. You add 3 to both sides. Divide by 2. So I don't know how they want the answer, but it's either 1,003 divided by 2, or you can get a decimal from your calculator if you want. Any questions on that?
No, thank you.
Maybe double check that we answered them all.
Yes, it looks like I followed them.
All right. Let me know, what is next week looking like for you? Are you all done with math? What's going
Um,
on there?
I have a final